Okay, hello, my beautiful people. Today I'm going to do grade 10 trigonometry. So you can double tap on the screen, you can like the live, you can share the live with your friends and your uncles, your aunties, your dogs, your cats, your favorite animals. Share this live with all the beautiful people that you love, who you feel will need the live in their own lives. Grade 10 trigonometry is what we're going to be dealing with right now, and hopefully we can learn a lot from the topic itself, because trigonometry is an important topic. It covers a big chunk of the paper 2 aspect of your marks. Okay, so let's look at this following diagram so that we can gain a lot from the live. Okay, I hope you are ready. 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 Share this live, guys. Share it out. All grade 10s need this right now, so they need it. Share it out with them, and yeah, make sure that they get it. Let's please. Okay. All right, so let's go. In triangle ABC, okay, in what? In triangle ABC, angle A is equal to this symbol here. This symbol here, guys, is what in Greek we call alpha. All right, this symbol here is what in Greek we call alpha. So in triangle ABC, you can see triangle ABC, guys, is a right angle triangle because there's a 90-degree angle there. Okay, so in triangle ABC, so when we are reading in triangle ABC, we know that the type of triangle we are talking about here is a right angle triangle. Angle A is equal to alpha, right? This is a symbol in Greek that denotes the angle, right? Angle A, we call it alpha because we don't have the exact specific degree that this angle measures. Angle C, okay, angle C, you can see there, is called beta. So in Greek, we call this symbol beta or beta. AB is equal to 12. AB is equal to 12. No ways, guys. Okay, AB is equal to 21 units. Okay, there we go. AB is 21 units. AC is equal to 29 units. There we go. AC is 29 units. Determine the value of, now, the value of what? Sine alpha. Let's start there. We need to determine the value of sine alpha. So there is alpha, all right, and then sine. Okay, now guys, whenever we want to read from a right angle triangle the value of a particular defined trigonometric ratio with its accompanying angle, mind you guys that every angle, okay, is assumed to be acute, and by acute we mean the angle is between 0 and 90 degrees. Okay, so what are we saying? We're saying sine of alpha is equal to, so what we usually then do when we are defining a angle with its given trigonometric ratio is we ask ourselves a few questions. One, where is alpha? That's a very important question that you need to ask yourself before you even get into the definition of the angle. First, ask ourselves ask ourselves, where is alpha in the triangle? Okay, that's the first thing you need to ask. Where is alpha in the triangle? 2, what is the definition of the given trigonometric? What is the definition of the given trig ratio? What is the definition of the given trig ratio? That's the second question you ask yourself. Then 3, in relation to the given angle, which is alpha in this case, what is the opposite side, adjacent side, hypotenuse side? And then you write the ratio in relation to the triangle's sides. Okay, so this is very, very important as we answer questions related to trigonometry. So I repeat again, in triangle ABC, this triangle, angle A is equal to alpha, angle C is equal to beta, angle, and then AB is equal to 21 units, AC is equal to 29 units. Determine the value of sine of alpha. Okay, so what we are going to first do before we even jump into this, right, is to just make sure that our triangle has all the necessary components, meaning it has all the sides and all the angles. So when we look at this triangle, we can see that we have 90, alpha, beta. So each angle in the triangle is defined. If you look at the sides, we have 21, we have 29, but we don't have the side BC. So before we even answer what sine alpha is, let's first check, guys, how would we get the missing side BC, given that we have two sides of a right angle triangle? What would we do in order to find the missing side of a triangle, given that we have the two other sides of the triangle? This is a right angle triangle. We have two sides given to us. We need BC. How do we find BC in a right angle triangle, given that we have AB and we have AC? Yes, user 6997037582790 whoever you are. Yes, we use Pythagoras. So in order to find a missing side, given that we have two sides, we can use the theorem of Pythagoras to find the missing side. What does the theorem of Pythagoras tell us? Theorem of Pythagoras says the following: the square of the hypotenuse side, meaning AC, the square of the hypotenuse side. How do we know that AC is the hypotenuse side? Because 90 degrees is always opposite the hypotenuse side. This is very important. 90 degrees is always opposite your hypotenuse side. So that is how I know for a fact that AC is my hypotenuse. This side AC is my hypotenuse. 90 degrees is always opposite the hypotenuse side. So I'm going to say AC squared is equal to, so Pythagoras says the square of the hypotenuse side is equal to the sum of the what? Of the square of the other two sides. The sum of the square of the other two sides. So I repeat, theorem of Pythagoras says the square of the hypotenuse side. How do I know that AC is the hypotenuse side? It's because 90 degrees will always be directly opposite my hypotenuse side, the longest side of the right angle triangle. So the square of the hypotenuse side is equal to the sum, meaning plus, the sum of the square of the other two sides, meaning AB squared plus BC squared. That, guys, is the theorem of Pythagoras. Then all I do is I substitute what is given. So AC squared, that's my 29 squared. BC squared is what I am looking for. AB squared, that's my 21 squared. Now I need all my geniuses and all my calculator people to help me out. What is 29 squared and what is 21 squared? Okay. 29 squared, I take my 21 squared over minus 21 squared. The 21 is positive squared, so I take it over to the left hand side. It becomes negative 21 squared. I isolate BC squared. What's 29 squared, guys? And what is 21 squared? What's 29 squared minus 21 squared? If my people are failing to help me out, I can help myself out. So let's go to my calculator. 29 squared minus 21 squared equal. There we have it. It's 400. It is 400. That's BC squared. But then I do not want BC squared. I want BC. So I'm going to take the square root on both sides. And when I do that, it allows me to put or have plus minus. Since this is an equation, I'm going to put plus minus because BC can either be a positive value or a negative value. That is something that I need to take into consideration. But what is the square root of 400? So I go to my calculator and I say, what's the square root of 400? I get 20. So that means BC can either be a positive 20 or a negative 20, but we conclude we reject the negative answer because a length of a side can never be negative. A length of a side can only be positive. So therefore, BC is equal to 20 units. That is BC. Now I can complete my right angle triangle and fill in the missing side. I now have all three sides of my right angle triangle. And so because I have all my three sides of the right angle triangle, as well as the defined angles alpha, beta, 90 for all three angles of the triangle, that means I can now extract from the triangle and be able to tell the people what sine of alpha is, because I don't have to worry about a missing side of the triangle. So now that we are in the position, because all sides of the triangle have now been found and all angles of the triangle are actually indicated, we can now determine the value of sine of alpha. So remember, what did I say are the questions we need to ask as we, take the leap of finding what sine alpha is? The first question is we need to ask, where is alpha in the triangle? Why are we asking where is alpha in the triangle? Because the angle of sine, which is acute, is alpha. So where is alpha in the triangle? Let's go and locate alpha. Here it is. There it is. 2. What is the definition of the given trigonometric ratio? So in other words, What is the definition of sine for a right angle triangle? What is the basic definition of sine? Okay, now to help us out with that, we need to just remember this important SOH for sine, CAH for cos, TOA for tan. SOH for sine, CAH for cos, TOA for tan. So we say this is SOHCAHTOA, and this will assist us in being able to remember what the definition of the given trig ratio is. So sine, guys, the definition of sine is actually equal to what? It is the opposite side over the hypotenuse side. So we go to the triangle and we're like, okay, since this is the angle we are referring to, which side is the opposite side of angle alpha? Which side is the opposite side of the given angle alpha? Which side is the opposite side of the angle alpha? Which one is it, guys? Can anyone tell me? Which side is opposite angle alpha? Because I need to identify my opposite side. Be Mine says it's BC, and imagination then tells me that BC is actually equal to 20. Now, had I not done Pythagoras, I wouldn't know that BC is actually equal to 20. So thank goodness for Pythagoras, I was able to determine the side length of BC. Now I know that sine of alpha is actually BC. The opposite side is BC. What is my hypotenuse side of this triangle? What is my hypotenuse side of this very triangle? The hypotenuse side of the triangle is imagination says it's 29. Be Mine specifically tells me it's AC. So AC, all right? Now, if we substitute, BC is actually represented by 20. AC is represented by 29. Then the question is, can we simplify 20 over 29 any further? Or is this the simplest form that 20 over 29 can be represented as? Can we simplify this further? That's the question. Can we? Because if we can, we go ahead and simplify it. But if we can't, we leave the answer in this form. So Be Mine says no. Okay. Imagination also says no. So Be Mine and imagination, you are my people. And we leave the answer there in that form. Thank you very much. Okay. That is sine of alpha. Sine of alpha is, this is the opposite side indeed. And AC is the hypotenuse side. And when we substitute, indeed, BC is 20, AC is 29. Guys, we would be 100% correct if we went directly to just writing the value 20 over 29, right? Of course, this helps you to be able to set the tone and then you do the substitution. But there is no problem going straight ahead and saying sine of alpha is equal to, and you write the ratio value, 20 over 29. That's 100% correct. You would be doing nothing wrong if you did that, and then you simplify if possible. Let's move on to the next question. The next question says, what is tan of alpha? So we do the same thing. Where is alpha in the triangle? We go to the triangle, we identify the angle alpha. 2, what is the definition of tan for that specific triangle? So tan we know is TOA, meaning tan is opposite over adjacent. That is tan, opposite over adjacent. Okay, tan is opposite over adjacent. Okay, that's very, very important. tan is opposite over adjacent. Exactly. So we go to the triangle, we're like, what side is the opposite side of this given angle? Alpha. Because we are dealing with alpha, which side is opposite to alpha? And then which side is the adjacent side? We then identify those and then we substitute. Imagination says 20 over 21. Okay. Imagination. You are using that imagination. Very nice. As we say 20 over 21, we have just over 20 viewers on my live, varying from 20 to 21, and so it goes. Okay, so indeed, this is the opposite side. The adjacent side, the word adjacent means the side that is next to the actual angle. So the side that is next to the angle is AB. All right. Though you may think it's also AC, remember AC is defined as the hypotenuse side. So we immediately reject the idea that the side next to the angle has to be AC, because AC is directly opposite the 90 degrees, and we know that 90 degrees is always opposite the hypotenuse side. So AC is the hypotenuse. So there's no ways that AC can be the adjacent side. The only side that can then be at the adjacent side to the given angle has to be AB. Okay, so that is why we say BC over AB. But of course, our substitution leads us to 20 over 21. Can we simplify this any further? No. Let's move on to the next question. Cos of alpha. Same question. Where is alpha? There is alpha. What is the definition of cos? So we go to our, what is cos? Ka, meaning adjacent over hypotenuse. That is cos. Cos is adjacent over hypotenuse. Then, if we say adjacent over hypotenuse, in the given triangle, which one is the adjacent side? In the given triangle, which one is the adjacent side? Yes, be mine, adjacent over hypotenuse. Which side is the adjacent side in relation to this angle? Alpha. And which one is the hypotenuse? So what would be the answer? Okay, definitely be mine. The adjacent side is AB. Okay, which means it's 21. Very good. Which one is the hypotenuse side? Exactly, the hypotenuse side is AC, which means AC is then equal to exactly. So exactly 29. So we can say then AB over AC, which when we substitute we know is 21 over 29. And that's it, guys. Can we simplify any further? No, we leave it just like that. 4 cos of beta. Okay, so once again, cos of beta. Question that we ask before we ask we ask ourselves, where is beta? Beta, where is it, guys? You can see where beta is. Beta is down here. Now we are changing our frame of reference. We call this the frame of reference. We are changing our where we are looking. So now we are here. We're asking ourselves, where is beta? There is beta. Then we ask ourselves the second question, what is the definition of cos? Okay, what is the definition of cos? What is the definition of cos? Okay, so that's very important. We are looking at this angle, we're asking ourselves what the definition of cos is. It's ka, meaning adjacent over hypotenuse. So in relation to this angle, what side is the adjacent side and what side is the hypotenuse. So what would be the ratio of cos of beta? Cos of beta. Cos of beta. Okay, imagination says 20 over 29 because the adjacent side is 20. So he says, and the hypotenuse side is 29. What is everybody else then saying? Okay. So cos of beta. Yes, guys, cos of beta is BC over AC, which means we have 20 over 29. Okay. Yeah, definitely. 5 tan of beta. Tan of beta. So once again, where is beta? Here is beta. What is the definition of tan in relation to the triangle and in relation to this angle? Tan, the definition of tan is towa, opposite over adjacent. So opposite over adjacent. Which one is the opposite side? Which one is the adjacent side? Exactly. Machias, yes. Opposite side is 21, adjacent is 20. Very good, very good, very good, very good, very good. Very good. We have 21 over 20. Okay, in relation to this angle, this is the opposite side. In relation to this angle, this is the adjacent side. Very good, very good. Sine of beta. So once again, where is beta? Here is beta. What is the definition of sine? So, opposite over hypotenuse. Where is the opposite side in relation to this angle, and where is the hypotenuse in relation to this angle? Because our frame of reference has changed. We are no longer looking at this angle, we are looking at this angle. In relation to beta, which one is the opposite side? Which one is the hypotenuse? Machias is on fire there in the comment section. It's like Machias joined in the live lesson and already fiery furnace there. Eh? Machias is like a fiery furnace. Okay, very good. This is the opposite side. That is the hypotenuse. It's definitely 21 over 29, and we can't simplify this any further. 7. What is cosec of beta? Now we are stepping into some other territory. What is cosec of beta? So what is this, first and foremost? Before we even, okay, we obviously look at the angle beta and we ask ourselves, where is the angle beta? Beta is here, all right? Then cosec, what is cosec? Okay, cosec is what we refer to as the inverse or the reciprocal of sine. Cosec is equal to 1 over sine. Okay, let's say we're just talking about theta as a general acute angle. Cosec is simply the inverse of sine. In other words, if sine is opposite over hypotenuse, then cosec is going to be hypotenuse over opposite. It is the reciprocal or inverse of sine. Okay, So stated in another way, whenever we are given the trig ratio of cosec and we want to express cosec in terms of the basic trig ratio, we always convert cosec to 1 over sine. That is basically how we express cosec. But if we want to write down a ratio for a specific triangle where we are asked what is cosec, then it is very important to note that the reciprocal or the inverse of sine is cosec. So if sine is opposite over hypotenuse, then it stands for to reason that cosec is hypotenuse over opposite. And this is something we need to take note of. So once again, we come back, we ask ourselves, where is angle beta? So we go to the triangle, we locate angle beta. Here it is. Then we ask ourselves, what is the definition of cosec? We know that cosec is the inverse of sine. So if sine is so opposite over hypotenuse, then cosec is hypotenuse over opposite. So we go to our triangle, we have our angle beta, which we are referring to. The hypotenuse side is 29, and the opposite side of this angle beta is 21. So therefore, cosec of beta is 29 over 21. It is hypotenuse over opposite. So we are going to say AC over AB, just to sort of like indicate using the sides of the triangles. AC, the hypotenuse, over AB, which in other words substituted is 29 over 21. Can we simplify this any further? No. This, guys, is how we express the trig ratio cosec. All right, 29 over 21. It is the inverse of sine. Sine beta was 21 over 29, but you see cosec is 29 over 21. It's like we flipped the fraction of sine beta around, and that is basically the reciprocal of sine cosec. Okay, 8 cot of beta. Cot beta. What is cot? Once again, guys, we know the basic trig ratio, sine, cos, and tan, but now cot. So let's first locate where angle beta is in the triangle. There it is, angle beta. That's the first thing we do. Where is beta? There it is in the triangle. 2, what is the definition of cot? Okay, now cot, guys, is generally spoken to be the inverse or the reciprocal of tan. 1 over tan theta gives us cot. Cot can be expressed in terms of tan as 1 over tan. And this is something you need to know because it is helpful and useful in certain situations. Okay, so that means, in other words, that tan has a inverse that is cot, and cot is going to be adjacent over hypotenuse. If tan is opposite over adjacent, then cot is adjacent over hypotenuse. As a reciprocal trig ratio, cot is expressed as adjacent over hypotenuse. Okay, so if we come back now, what is the definition of cot? Cot beta, to be specific, we are looking at this angle and we are asking ourselves, what is the definition of cot? We've just learned that it is adjacent over, not hypotenuse, but opposite. Okay, just a minor error there. Remember, I said the reciprocal of tan is cot. If tan is opposite over adjacent, then cot is adjacent over opposite. Okay, sorry guys, my mistake earlier on. If tan is opposite over adjacent, then cot is adjacent over opposite. It's the reciprocal, the reverse, the inverse. So therefore, if I'm going to say cot beta, there is angle beta. I'm going to locate my adjacent side. What is the adjacent side of angle beta? It is BC. What is my opposite side of angle beta? It is AB. So cot then is BC over AB. In other words, it is 20 over 21. So cot beta is BC over AB, which in other words is 20 over 21. That is the expression of cot beta. Because as I said, cot is the inverse, the reciprocal of tan. Tan is opposite over adjacent, TOA. So cot is adjacent over opposite, my beloved grade 10th. So very, very important. Okay. Then number 9, sec. Sec beta. What is sec? Okay. So once again, what we have here is unbeknownst maybe to some of us, but known to some. So once again, we ask ourselves, where is angle beta in the triangle? There is angle beta. Then, what is the definition of sec in our triangle? Sec, be very careful with the imagination. Sec is the reciprocal of cos. Okay. So generally speaking, if I want to express sec in terms of cos, then I say 1 over cos. But then remember, that means that cos, the reciprocal of sec. Sec will always be, if cos is ka, adjacent over hypotenuse, then sec is hypotenuse over adjacent. Okay. If cos is adjacent over hypotenuse, then sec is hypotenuse over adjacent. If cos is adjacent over hypotenuse, then sec is hypotenuse over adjacent. So what is the definition of sec? Hypotenuse over adjacent, as Tando has said in the comment section. Therefore, what is sec of beta? Let's go to the angle beta and then ask ourselves, what is the hypotenuse side in relation to this angle? It is AC, which is 29. What is the adjacent side in relation to this angle? It is BC, which is 20. Can we simplify this fraction any further? No. So that is basically the expression of the trig ratio sec. Okay, guys, this is not in any way difficult. Okay, so the basic trig ratios are SOHCAHTOA. The reciprocal trig ratios trig ratios are CHOSHAKAWO. CHOSHAKAWO. We've got SOHCAHTOA and CHOSHAKAWO. Bien, I got CHOSHAKAWO. Okay. How do you like CHOSHAKAWO? Okay, we've got SOHCAHTOA, which is the basic trig ratios, but then the reciprocals are CHOSHAKAWO. Okay, I think this may well be our Chinese getting into the, I don't know. It's like SOHCAHTOA, and then CHOSHAKAWO. Yeah. Okay, So yeah, this is basically our basic trig ratios, SOHCAHTOA, and then our reciprocals. Cosec is hypotenuse over adjacent, sec is hypotenuse over adjacent, and then cot, sorry, is adjacent over opposite. Just important, very, very important to know that cosec and sine, reciprocal, cot and tan, reciprocal, sec and cos, reciprocal. Okay. Mr. Loneheart, reciprocal is now noted. I won't forget it next time. What, didn't you know it the first time? Oh heck, another hour of algebra. What do you mean? What do you mean another hour of algebra? Imagination. Okay. Yeah, guys, remember that in mathematics, algebra is basic to mathematics. Okay. Algebra is basic to mathematics. And so when we do not, for remembering, oh heck, another hour of algebra for remembering. I don't know. I kind of lost the imagination. Yeah. But remember, if you have these up somewhere, because these are the things that I'm saying you guys need to make sure that you post up on your walls. On your walls, in your room, behind the fridge, the recipes, your mom needs to take down the recipes from the fridge. You need to put up the algebra, put up the trigonometry. You don't want to forget these things, because these are things you need to remember for the next 3 years for yourself, so that the trigonometry continues to flow, right? Nicely, uninterrupted, no problems. Okay. Yeah. So I'm hoping that, let me just add 2 more here. When are you doing grade 12 double angle and compound angle? This is not the place. This is grade 10. This channel is for grade 8, 9, 10, this one. The other one, the one with the white profile picture, that's where I do grade 11 and grade 12. So if I'm not there, then don't ask me grade 12 stuff here. Here I'm focusing on the grade 10s who are still coming into the, coming into this. Grade 10s are learning, trigonometry for the first time. So yeah. Okay, guys, what if they asked what cosec alpha is for a grade 10 learner? Cosec alpha. Cosec alpha specifically. Thank you guys for the double taps. I appreciate them. I appreciate the likes there. We've got 1.5k likes so far. Remember that supporting the live does not necessarily always mean gifting. I know most of you don't have the capacity to gift, but if you can double tap on the screen as well, guys, get the likes up there. That helps a lot, because it gets the live onto the FY for you page, and more people can actually see and join in, and hopefully have the opportunity to rehash on important things. So I appreciate those who double tap. Appreciate those that do gift if you can. That's always nice. But yeah, double tapping, guys, is really helpful. Let's look at cosec alpha. Okay, once again, where is alpha? There is alpha. You always first check where the angle is. Go first there, then the definition follows after identification of the angle in the diagram. Identification of the angle, definition of the trig ratio, and then the sides, of the triangle in relation to the given angle, identifying them. So cosec, we know, is the reciprocal of sine. So sine is opposite over hypotenuse. So cosec is hypotenuse over opposite. So we go there and we're like, which one is the hypotenuse side in relation to alpha? Which one is the opposite side in relation to alpha? Then we express our ratio for cosec. You see? Yeah. So cosec alpha is, let's see in the comment section, you guys can help me out. Cosec alpha is cosec alpha is, where is alpha? Here is alpha. What is the definition of cosec? Cosec is hypotenuse over opposite. It is the reciprocal of sine. So where is the hypotenuse side in relation to alpha? There is the hypotenuse side. Where is the opposite side in relation to alpha? There is the opposite side. So what is the definition of cosec alpha? It is 29 over 20. Okay. Then what is the definition of cot alpha? Okay, so once again, where is alpha? There is alpha. What is the definition of cot? Cot is the inverse of tan. Tan is TOA, opposite over adjacent. So cot is adjacent over opposite. So which one is the adjacent side to this angle? It is BA. Which one is the opposite side to this angle? It is BC. So what is the ratio? 21 over 20. Okay, I think you guys get the point. You get the gist of the matter, right? You get it well. Yeah, I think lastly, let's just say what is sec of alpha. Sec of alpha, I repeat, sec of alpha. Where is alpha in the triangle? There is alpha in the triangle. What is the definition of sec in relation to this triangle and the given angle? So sec is the reciprocal of cos, and sec is hypotenuse over adjacent. So which basically side represents the hypotenuse side? It is AC. Which side represents the adjacent side? It is AB. Therefore, the ratio that we should write down is exactly, Mr. Loneheart, 29 over 21. Now that wasn't too bad, was it? Yeah, okay. Guys get the point. Guys get the point. Guys get the point. Guys get the point. Okay, in relation to this triangle, here's a triangle. We need to give the following trigonometric ratios in terms of A, B, and C. Write down trig ratios in terms of A, C, B. So what's sine of theta in terms of A, C, and B? This one I'm not going to do anything. I'm just going to allow you guys to comment in the comment section. I'm just going to wait for you to answer. What is sine of theta, guys, in terms of A, C, and B? Okay. This is R, that is theta here. That's alpha, the angle. And then the sides, A, that's B, that's C, that's a 90-degree angle. So what's sine of theta? Okay, Pumla says B over C. Okay, Pumla, I need you to change that question mark into an exclamation mark. I need you to be sure, not iffy, or not doubting yourself and what you have actually said. Okay, I need people to be a bit more confident here. Okay, sine of theta. Theta is here. RST, but yeah, turned off. Thank you so much there. But remember, I want our sides in terms of A, C, and B. Okay. Okay, the real Aya said A over C. Mr. Loneheart said A over C. Pumla says B over C. Okay, so let's go and check this out. Definitely says Stephen Musa. Thank you so much. Mathematics is a universal language. So there is theta. The angle is there. Theta, there's the angle. Then in terms of theta, guys, the angle we are referring to is theta. Where is theta? There is theta. So we are looking here. Then we ask ourselves, what is the opposite side of this given angle? Because remember, sine is opposite over adjacent, opposite over hypotenuse. Sine, so, is opposite over hypotenuse, O over H. So which one in relation to this angle is the opposite side? The opposite side of theta is B. Which side is the hypotenuse side in this triangle? It is C. So Tando 13 and the real Aya, be very careful. Pumla, it was 100% correct, but Pumla, instead of confidently saying it's B over C, said B over C with a question mark, which means you were not sure. We need to be sure, okay? Guys, remember, where is theta? This is where you refer when you are looking at the opposite side in the hypotenuse. This is your angle. So this is your go-to guy. And then you ask the go-to guy, who are you opposite? Mr. Go-To Guy. Mr. Go-To Guy is opposite B, so that's the opposite side. Who is your hypotenuse side? Obviously, the hypotenuse is always opposite the 90-degree angle, so it's B over C, no doubt. Okay, 2 cos of theta. Isn't B the adjacent side? Now, be very careful, all right? The person who's saying isn't B the adjacent side, which angle are we referring to? Guys, remember your opposite and your adjacent side depend on the angle you are referring to. Here they are asking for sine theta. So when we say sine theta, we ask ourselves, where is sine theta? And we say here is sine theta. So if you look at this angle, your opposite side is the side opposite the angle that we are talking about. So opposite the angle we are talking about is B. Okay, ST is the side opposite this angle. RS or A is called the adjacent side in relation to the angle we are talking about. Okay, so be careful. The angle, you must always look at the angle. This is what gives you direction as to whether who is opposite, who is adjacent. Okay, so look at this question as well. Now we are being asked, what is cos theta? Okay, so first question we ask ourselves, where is theta? There is theta. Then in relation to this angle, what is the definition of cos? Cos is ka, meaning adjacent over hypotenuse. So in relation to the angle theta, which one is the adjacent side? The adjacent side is, very good, Tando 13. The adjacent side is A, okay? Then in relation to this angle still, which one is the hypotenuse side? The hypotenuse side doesn't change, it is C. Hypotenuse is always opposite the 90-degree angle. So A over C, 100% spot on. Number 3. Okay, guys, be careful. Okay, so the important lesson here you need to walk away with, and that is always check the angle that we are referring to. Define your opposite side and your adjacent side according to the angle given. Check the angle we are referring to and define your angle, your side, your opposite side, and your adjacent side in relation to the angle given. Okay? So tan theta, TOA, that's the definition, opposite over adjacent. So where is theta? There is theta. Which side is opposite theta? Because that's your opposite side. You see? Which side is opposite theta, guys? Please, guys, please. Tando, you're being careless. Okay? Guys, I'm not gonna lie to you. If you keep on making mistakes over and over again, you are not concentrating. Your concentration is not up to speed. Some of you keep on making mistakes that are very silly. You keep on guessing wrong. Where's the adjacent side? Where's the opposite side? But this is so basic, because all you need to do is identify the given angle. Then you use that given angle to say, okay, who's this side? This is Mr. Adjacent to this angle. Who is this side? This is Mr. Hypotenuse side to this angle. Who is this side? This is the opposite side. Now, are you trying to tell me that you guys are struggling to identify the adjacent and opposite side? Are you really serious? Okay. Is that kind of carelessness really acceptable, guys? And are you guys satisfied with continual haphazard mistakes like over and over again? Are you guys happy about that? Hi guys, I can't. No. So that is why you need to decide once and for all that you are just going to concentrate, focus, and make sure that you get this 100% correct all the time. Okay, because this is simple identification as per your definition in relation to a given angle. Okay, so please, let's focus, man. Let's focus, people, please. Like, get your game on. Get your A game on. Okay, so tan of theta. Where is theta? Here is theta. All right. Then, what is the definition of tan? Tan is TOA, opposite over adjacent. Opposite side, who is opposite? Theta. Yes, says Stephen Musa and Mr. Lonehart. Very good. And Pumla. Okay, finally getting your A game on. B, which is the opposite side, adjacent side is A, B over A. Okay. 4. Cos of alpha. Cos of alpha. Okay, guys, in the comment section, now I'm expecting no one to be making mistakes. Okay. Once again, the angle, where is it? Here. So now we have changed our frame of reference. We are looking at things with new eyes. Please, guys, you are looking at things with new eyes. You are no longer looking at this angle. You are looking at this angle. You are using it to refer to your opposite and your adjacent side. So once you change your eyes and you look elsewhere, okay, right? I don't understand this thing. So they tell you this is your wife. Where now when you are defining things, you are looking at somebody else's wife and you are defining things in relation to somebody else's wife. That's where cheating comes in. No, guys. Cos of theta. You keep your eyes here. Don't take your eyes there now. You see, look at the angle that they are referring to. That's why I keep on asking this question. Whenever you are given a trig ratio with an angle, please, guys, ask yourself, where is that angle? Go to it, that angle. Now we are here. We are no longer dealing with theta. We are dealing with alpha. So now you ask yourself, what is the definition of cos in relation to this angle? Cos is adjacent over hypotenuse. Which one is the adjacent side to this angle? Not to theta anymore. This angle. Please, guys, please. We are always changing things whenever the angle changes, and we go to that angle and we ask ourselves, who is the adjacent side? Who is the opposite side? But our eyes are fixed on alpha, not fixed on theta as we determine adjacent and opposite. We are fixed on alpha. Lock in, guys, lock in. Please lock in. Lock in. Lock in. Lock in. Cos of alpha. You are here at alpha. What is the definition of cos? Cos is ka. In other words, adjacent over hypotenuse. In relation to this angle, what is adjacent? Adjacent is the side next to. So it can only be B. It can't be C. Guys, the adjacent side of alpha can't be C. Why can't it be C? Because always opposite 90 degrees. What do we have always opposite 90 degrees? We have what we call the hypotenuse side. Guys, the hypotenuse side does not change, man. So you can't call the hypotenuse side your adjacent side, man. Adjacent means next to, and the only side that can legitimately be next to the angle alpha is side B. Tando 123, thank you. Awuyazi maths. I don't claim to know it at all, actually. You are very correct. I don't know maths. You know, I don't know maths. That's why I'm hoping with all of my heart that these kids who are here can know it on my behalf. And then in the test, they can do well. So thank you so much for telling me something that I already know. You are amazing. Tando, I love you. Okay, so alpha, guys, is here. Who is the adjacent side? Give B, Pumezo. Thank you. Give B. So it's B. Thank you. Over what, guys? Whose hypotenuse? Yes, Pumezo. Give C. Thank you so much. Thank you so much. Thank you. Thank you so much. Give B. Adjacent side. Give B. Then hypotenuse. Give C. When you look at this angle. Okay. Let's log in, guys. Let's log in. Let's get this thing down, man. Please, please. Tan of alpha. Tan of alpha. Where is alpha, guys, again? Where is alpha? It's here. What is the definition of tan? Toa. Opposite over adjacent. Soka toa. Toa. Opposite over adjacent. Okay. Opposite. Who is opposite alpha? Who is adjacent alpha? You see? Who is opposite? Who is adjacent? Pumla, thank you so much. We are resting now. We are following our name, Pumla. We are resting now. We are resting in truth. Okay. Who is opposite alpha? It's A, yes. Who is adjacent alpha? Oh, it is B, Pumezo. Very good, Blai. Tando, thank you so much. Tando 13 is really helping there. Tobani. Yes, Tobani. The one who is adjacent is B. So if we write down now the ratio in relation to A, B, and C, it is A over B. Yeah. Sine of alpha. What is sine of alpha? Sine of alpha. Tando 13. Tando 13. Pumla. Pumezo. Yeah, Pumezo, Pumla, and the Tando 13. I think you guys are flying with it now, eh? Yeah. Where's alpha? There's alpha. What's the definition of sine? Sine is opposite over hypotenuse. So it is A over C. True. A over C. Good, guys. Good job, guys. Good job. Good job. Those people there in the comment section are commenting very well. Very proud of you guys. Very, very proud. Very nice. Okay, very nice. Okay, let's change it up. Let's see now if you guys are cosec of theta. Cosec of theta. Cosec of theta. Cosec of theta. Take note of the angle. And then what is this? What do we know about it? You see? take note of the angle. What is the definition? Where is the angle? Then also, then after identifying the angle, what is the definition of this cosec? Still remember what the definition of cosec is? Therefore, what then is the answer for cosec? Yeah. So cosec, we must remember, is the reciprocal of sine. Cot is the reciprocal of tan. Sec is the reciprocal of cos. So sine is opposite over hypotenuse, but cosec is hypotenuse over opposite. That's why I said your reciprocal for cosec is cho. Then cos is adjacent over hypotenuse. The reciprocal of cos is sec, which is hypotenuse over adjacent. It's like the opposite. That's why we say sha. And then tan is opposite over adjacent, whereas cot, which is the reciprocal, is basically adjacent over opposite. So cho sha kao, that is basically the reciprocal. Okay, just remember this C stands for cosec, whereas this C stands for cot. Yeah, so it's something just because it may be easy to basically make a mistake about cosec and cot, but tan and cot are reciprocals, cos and sec are reciprocals, and sine and cosec are reciprocals, okay, or they are inverse ratios. So cosec, guys, okay, theta, where is theta? There is theta. So if theta is there, what is the definition of cosec? If cosec is the inverse of sine, okay? Be very careful, guys. Very, very careful. What is the inverse of cosec? Okay, what's the ratio of cosec if the inverse of cosec is sine? Okay, cho. So basically cosec is hypotenuse over opposite. Hypotenuse over opposite. That is C over B. Hypotenuse over opposite. There is theta. This is the hypotenuse side. To theta, that is the opposite side. So it is C over B, not C over A. So it's Mr. Loneheart alone that got this one correct. Okay, yeah, you guys need to get familiar with the reciprocal trig ratios. What is sec theta? Okay. Cos is adjacent over hypotenuse. The reciprocal of cos is sec, which is hypotenuse over adjacent. Okay, sec is hypotenuse over adjacent. It's the reciprocal. Sec is hypotenuse over adjacent. So we go to theta. Where is theta? There is theta. And we ask ourselves, what is the definition of sec according to the referred angle, which is theta? Okay. Remember, sec is hypotenuse over adjacent. So that means what? There is the hypotenuse side. There is the adjacent side. Yes, Tando 13, 100%. Mr. Loneheart, 100%. Pumes Oplai, 100%. So we have C over A. Hypotenuse over adjacent. C over A. That is sec. Okay, very good. 9. Cot alpha. What is cot alpha? What is cot alpha? Okay, remember, cot is the reciprocal of tan. So tan is TOA, opposite over adjacent, whereas cot is adjacent over opposite. But remember, we are now referring to which angle? Alpha. So our angle of reference is this one. And we know that the definition of cot there is adjacent over opposite. Adjacent over opposite. Adjacent over opposite. Let's be very careful. Not opposite over adjacent, but adjacent over opposite. And we are referring to this angle, not to the other one. So you see, we are referring to alpha. So where are we looking? Here. Okay. And we're looking at adjacent over opposite. Okay. So what is the adjacent side to this angle? It is B. What is the opposite side to this angle? It is A. So the answer is B over. Okay, very good, Pumezo. Pumezo Blai was the only one that got that one right. 100% on point. 10. Sec alpha. What is sec alpha? Okay, so once again, sec. What is sec, guys? Remember, sec is the reciprocal of cos. Cos is adjacent over hypotenuse. Sec is hypotenuse over adjacent. So when we say sec alpha, we are referring to which angle? That angle. So when we look at that angle, we ask ourselves, what is the definition of sec in relation to this angle? It is hypotenuse over adjacent. Sha. Okay, hypotenuse over adjacent. So with relation to this angle, who is the hypotenuse side according to this angle? In relation to this angle, who is the hypotenuse side? And then who is the adjacent? Because we're saying hypotenuse over adjacent. Okay, Pumezo Blai 100%. Tando 13, very good. Who else is coming in and answering for us here? Besides Pumezo Blai and Tando 13. Seems like Tando 13 and Pumezo Blai are the only ones that are really participating in this exercise, eh? Sec of alpha. Where is alpha? There is alpha. What is the definition of sec? Sec is hypotenuse over adjacent. In relation to this angle, which one is the hypotenuse? It is C. In relation to this angle, which one is the adjacent? It is B. So yes, you guys are 100%. It's C over B. Very good, Mr. Loneheart. 11. Cosec of alpha. What is cosec of alpha? Cosec of alpha. So once again, where is alpha? There is alpha. What is the definition of cosec? Cosec is the inverse of sine. Cosec is the inverse of sine. What is sine? Sine is opposite over hypotenuse. So sec is hypotenuse over opposite. So in relation to this angle, hypotenuse side is, opposite side is, hypotenuse side is, opposite side is. What would be the ratio? According to this angle, hypotenuse side is, opposite side is. This angle, the hypotenuse is C, but this angle, the opposite side is A. So hypotenuse over opposite is C over A. Alwande, thank you so much. Okay. Thanks for lesson. Pumezo Apply. You're welcome. You're welcome. So guessing this is making sense.